Hi, Ashley. I'm going to give you a quick tutorial here on derivatives, and I'm going to skip some of the theory behind derivatives and get more emphasize more just how to use derivatives to solve problems and sort of the mechanics of finding a derivative. But at some point, you probably do need to know the theory behind derivatives, and in your textbook, the key section starts on page 740. But let's just, again, skip ahead to the practical mechanics of understanding what a derivative is and how to find it. So let's say you have some bizarre function, which I've drawn here, and we don't know exactly what that function is, but it doesn't matter for now. It's just y equals f of x. Y equals some function of x. So this is x, this is y. And once we can see the function or can define it, we can talk about the change in y divided by the change in x, or delta y over delta x. You might hear that frequently. Delta y over delta x. Well, that number, that ratio depends on 2 points. You have to actually choose a point, let's say here, and then choose another point in order to compare the change in y over the change in x. And it turns out that what we're talking about here is just a ratio, which actually we can represent as a straight line, because delta y over delta x is also the equation for a line, a straight line. So let's say delta y over delta x equals 13. Well, that means that we can also write delta y equals 13 times delta x. And that's basically the equation of this line. It has a slope of 13. So that's delta y over delta x. So the next step is on the next page. Instead of talking about delta y over delta x, we define a ratio of dy over dx. And this you can think of as the instantaneous change in y over a tiny, tiny, tiny change in x, an infinitesimally small change in x. How much does y change? Well, here again, you have to find that exact value. It depends on where you are on the curve, right? So dy, let's take this point here, dy dx, this is actually going to have is a line sloping downward, so it's negative. You can see that right away. And effectively, this line is the tangent at that point. So again, just like the last example, delta y over delta x, we're dealing with a line here, but it's tangent at that one particular point, whatever x is. But the point is that dy dx is not constant for this function. It depends on where you are in the curve, right? So what that means is this is itself a function of x, because it depends on where you are on the curve. So we define that function as f prime x. F prime x is also known as the derivative of f of x. And the derivative is also known as dy dx. So these are just different labels for the same thing. So basically, when you're asked to find a derivative, you're being asked to find an equation. First of all, yeah, an equation for the rate of change over the entire curve. But then if you're asked to find the derivative or the value for the derivative at a particular point, then what you do is you plug x into this equation to find dy dx. So let's take some examples, and that'll come up in the next video.